Welcome back. This is lesson 9 in our second unit in Algebra 2. This unit has been all about studying functions, and now we're starting to look at a couple of different examples of functions that we'll see from time to time. One of those is linear, and the other is absolute value. In the previous lesson, we looked at how to graph absolute value equations under a variety of transformations. In this lesson, I want to get into solving them algebraically. In order to kind of bridge from what we did in the last lesson to what we're doing now, and to hopefully build your intuition to how solving these equations work, I'd like to start by solving by graphing. When solving an equation by graphing, there's really two popular ways to do it. You can set the entire equation equal to 0 by moving everything from one side over to the other, then graphing it and finding the what we call zeros, or where they cross the x-axis. The other popular way is to graph the left-hand side as one equation, the right-hand side as another equation, and see where the equations cross. And that's the method I'd like to do today. So let's start by graphing the left-hand side of this equation. The left-hand side of the absolute value of x minus 1 equals negative 1 half x plus 2 is simply the absolute value of x minus 1. So I'm going to start here at 1 because I'm shifted to the right 1. We know that the absolute value graph is a graph that goes up 1 over 1 to the right and up 1 over 1 to the left, making a V. But the minus 1 on the inside, remember insiders lie, is a shift to the right 1. So we end up with this shape going that way and this other shape going this way. If you're following along with a note handout from my webpage, you may note that I've kind of beefed up this graph here. I want to be just a little bit more careful, but a sketch is really fine. But in order to make this presentation, I wanted to be a little more careful. So I put in a better looking graph. All right, I'm now going to graph the right-hand side, which is negative 1 half x plus 2. Recall, we're looking for where these two functions intersect, and those intersection points are going to be the x values that are our solutions. So 2 on the y-axis, and I'm going to go down 1 and to the right 2 because this is a line with a slope of negative 1 half. Likewise, I can go up 1 and to the left 2. And I think we could see the line there. Something kind of like that, right? You can see that there are actually 2 points of intersection on this graph. We have an intersection at x equals 2, where the y values of both the left and the right-hand side are 1. And we have an intersection at negative 2, where both the left-hand side and the right-hand side are 3. So our solutions to this equation are 2 and negative 2. Be mindful not to include the y values when giving your solutions to an equation that you did by graphing. Nobody knows that we graphed it. They didn't ask us to graph it. They asked us to solve the equation. The y values just tell us that we got the right answer. The x values are the ones that we're looking for. All right, let's do another practice problem where we solve by graphing. Once again, though, I think I would like to get a little bit better graph. So I'm going to grab us a slightly better looking graph. Yeah, there's one on a previous page from a while ago. I think I can borrow that one. There we go. My apologies to those at home that are having to deal with an inferior graph, but you know, you can cut and paste your own graph paper too. All right. We're going to do negative 2x minus 1. Okay, so this is a little bit of an unusual graph here. This is going to be a bit of a challenge. And there's lots of different ways that we could do it. We could just plot values, put in x, and see what comes out for y. But even though this is a pretty challenging one to do by hand for what you know so far, I'd like to kind of share with you how I would do it. You might be a little surprised. Well, it turns out we can bring a constant out of an absolute value. So if I have a constant that I can pull out of here and here, I will. But there's not a value in common to the 2x and the 1, but I'm going to do it anyway. I'm going to pull out the 2, and it's going to become x minus 1 half. And this is something we do a lot when graphing functions, is that we want to figure out what that transformation is. And so if we can actually factor it out, then we see that we have a vertical translation, a vertical stretch, and a horizontal translation to the right 1 half. We can't usually bring out constants from inside a function, but we can with absolute value. You just need to be careful that if it's a negative, you bring it out, it becomes a positive. Okay, so this has got a negative from the negative on the outside too, but we're actually moved over a half. So we're going to be right there, and we're going to go down 2 and to the right 1, but it'll still be in the half. And again, like I said, we could have just made a table of values and probably generated them that way. But I'm more interested in you seeing what this graph looks like and getting a feel for how we're going to solve equations and spending all day talking about how to graph this difficult one. All right, let's do another one. Let's do the right-hand side. Okay, well that's better. X plus 2, that's better. We know how to graph that. That's just a line at 2. Okay. Well, on the last problem when we graphed them, we got 2 solutions. This time we're getting no intersections. So already things are weird with absolute value, aren't there? We're seeing that we can get more than one answer, and we oftentimes will, but we're also seeing we can get no answers. And that's because of this V shape, that it doesn't travel the entire range of the y-axis, and therefore we have these spaces where we never go and they might not intersect. So we're going to be having to look out for how do we know when we're solving the equation if that happens? So we're going to have to be careful. Okay, let me just get to my next example here. All right, I got one more to graph, right? Okay. Once again, though, I'm gonna borrow that graph. I kind of like it. That one was a good one. Okay. Okay, this one doesn't look too bad. This is already a nice transformational form. So I'm going to shift, this is going to be shifted to the right 2. That's because insider slice, so it's going to be right 2, and then up 3. And then because of the negative, instead of going up and over, it's going to go down. And it's going to make this, 45-degree angles go down 1 over 1, down 1 over 1, down 1 over 1. This is going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. All right, now on this one here, the right-hand side, we have another line. I have negative 1 half x plus 4. So I'm at 4, and I'm going to go down 1 over 2. This time, we see that the two sides of the equations intersect exactly 1 time. And that's at the x value of 2. Remember, I'm just interested in the x values. So we've had 2 solutions, no solutions, and 1 solution. So lots of different things can happen. All right, now it's time for us to put away the graph paper and put our pencils to the paper and really solve this out. My instructions say to solve the following equations involving absolute value and to check for extraneous solutions. But we need to remember what an extraneous solution is. An extraneous solution is a solution to a derived equation, but doesn't satisfy the original one. So when you do algebra, we do a series of steps, and there's certain steps that never cause a problem. If I've got an equation and I subtract from both sides 4, perfect. That's a very safe move. The removing of absolute value bars as a step is not a very safe move. It allows us to have solution candidates, things that might be the answer, but it's just not a perfect step. And there's actually several of them you're going to learn. And anytime you perform those steps in an algebra problem, you need to make sure that you go back and check that your solutions are actual solutions, not fake wannabe solutions, called extraneous. So let's do it. All right. So to solve an absolute value equation, my goal is to isolate these bars right here. I'm trying to get these alone. Please keep in mind, absolute value is a big deal, right? You can't ignore them. You can't look at this, I'm not going to deal with those bars. You got to be thinking, okay, that made a V shape and that makes a line. I can get out all sorts of funny things happen. You gotta keep that in mind. This is a big deal. All right, subtract 4 from each side. You get x minus 3 in absolute value is equal to 5. Here comes the step to remove the absolute values. To remove the absolute value bars, you take what's inside the absolute value and set it equal to the negative and the positive of what it's equal. So why is it that we must do both of these? Well, let's think about what we're saying. We're saying that if what was in these absolute value bars equaled negative 5, then the absolute value of negative 5 would be 5, right? So that's why we need to consider what would make x minus 3 equal to negative 5, because negative 5 has an absolute value of positive 5. And then, of course, the traditional regular 5 would also have an absolute value of 5. That gives me x equals negative 2. And over here, this gives me x equals 8. And now I'll check both solutions. We've been practicing checking, and this is one of the main reasons why, is because sometimes checking is not just something your teacher tells you to do to be mean. It's because it's absolutely essential part of the solving process. The absolute value of 5 is 5, and 5 plus 4 is 9. And I'll check the other one as well. So I have 8 minus 3 in absolute values plus 4. Well, that's 5. The absolute value of 5 is 5. So that works as well. And so I'll put both of these solutions in my solution set because they both worked because we checked them both. All right, let's try the next one. Okay, this is a little bit different situation here. We have an absolute value equal to an equation involving x, but it's the same idea. Isolate what's in the absolute value bars. Get that alone. You can't do anything until you get those alone. And we have them alone. So that part of the job is done for us. You see what I mean by alone is that they are on the left-hand side is the entire left-hand side is inside absolute value bars, and everything that was not inside absolute value bars is now on the right-hand side, the other side, if you will. And so what we do is we take 2x minus 1, and we set it equal to the negative of x plus 3. And we're going to do the same thing to the positive. And it's this step that is so dangerous. When it's equal to a whole number like it was in part A, a positive number, we feel pretty confident about it. But this step here, I really don't know whether these answers will be extraneous or not, because that's a dangerous step that we just did. Let's solve. Well, it's not dangerous. It's the right thing to do. I just mean that I know that removing absolute value bars in a situation like that can cause extraneous solutions. So we got to be careful. I'm going to add x to both sides. And I'm going to add 1 to each side. I get x equals negative 2/3. I'll go ahead and solve this other side while I'm at it. And I'll add 1 to both sides. I get x equals 4. So we need to test each one of these expressions. I have 2 times a negative 2/3 is, well, I'll write it out. Don't want y'all to get mad at me for not showing my work. Okay, equals negative 2/3 plus 3. All right, so when you multiply a whole number times a fraction, you go top times top, bottom times bottom, reduce if you can. I can't reduce, but I get negative 4/3 minus 1 in absolute value bars. But that 1, we know that that 1 is 1 over 1. If I multiply the top and bottom by 3, I'll get 3 over 3, right? Which gives me a negative 7 thirds in absolute values, which is a positive 7 thirds. All right, this over here, I have negative 2 thirds plus 3 over 1. Well, that 3 over 1, that's really, I can call it 9 over 3 if I multiply the top and bottom by 3. And that gives me 7 over thirds. Huzzah! That worked. So that was a solution. And if you don't mind, I'm just going to go ahead and erase that part. Okay, so if you still need it, you're still having it down, go ahead and pause the video, but I'm going to erase it just to get myself a little bit more room. Since it was just my check and I've already established that it's correct, let's try the next one. I've got the absolute value of 2 times 4 minus 1 is equal to 4 plus 3. Well, that's 8 minus 1 is 7. The absolute value of 7 is 7. Well, that works as well. So it looks like both of these solutions are indeed solutions to this equation. All right, looks like I've still got my work cut out for me. I still got 2 more to do before you get to take over. So let's keep going. All right, I've got 2x plus 3 equals the negative the absolute value of x minus 2. I need to get these absolute value bars alone. And the way I'm going to do that is I'm going to divide both sides by a negative 1. There's actually quite a bit of things I could do there, but this kind of fits with what we've been doing. So let's keep going. All right, now that I've done that, I can set x minus 2 to the positive and the negative of this. So I can say that if I make it equal to the negative of 2x minus 3, I would get positive 2x plus 3 equals x minus 2. And if I set it to the negative of, no, that was the negative. If I set it to the positive, I would just get negative 2x minus 3 equals x minus 2. A little confusing because the positive version had negatives and the negative version did not, but that's because we negated a negative. All right, I'm going to subtract x from both sides here, and I get x plus 3 equals negative 2, which gives me x equals negative 5. All right, over on this one, I'm going to subtract x from both sides. Gives me a negative 3x minus 3 equals negative 2. I'll add the 3 to the other side. And I get x is equal to a negative 1/3. Now, at this point, I need to check. Let's try the negative 5 first. So I have 2 times a negative 5 plus 3 equals negative times the absolute value of negative 5 minus 2. So that's what? Negative 10 plus 3, that's a negative 7. This is negative. The absolute value of negative 5 minus 2 is negative 7. The absolute value of negative 7 is positive 7. So negative 7 equals negative 7 because I still have that negative on the outside. All right, let's try the other one. We have 2 times a negative 1/3 plus 3 is equal to negative the absolute value of a negative 1/3 minus 2. So that's a negative 2/3 plus 3. Now that's 3 over 1, so I'm going to multiply by 3 on top and bottom and get 9/3, and that gives me 7/3. Then over here I have a negative on the outside, and that's a negative 1/3, by the way. That's 2 over 1. 2 over 1, we could call that, if multiplied by 3 over 3, we call that 6 over 3. So this is a negative 1 minus 6 over 3. Sorry, negative 1/3 minus 6 over 3. So I end up with a negative times the absolute value of a negative 7/3, right? The absolute value of negative 7/3 is positive 7/3, but there's still that negative on the outside, so I end up with negative 7/3. Ooh. That's not the same. So this is a situation where we had one work and one did not. So I can only say that negative 5, not negative s. I know my 5s looks like s's. Negative 5 is the only solution because it's the only one that worked. And you could graph it and you'll see that what's, just if you're looking for a pictorial representation, what happened there? Well, this negative x minus 2 is shifted to the right 2. So this is a v like that. And then 2x plus 3 is something like this, and you see it's steep enough to catch that side over here at the x value negative 5 and a y value of negative 7, but it did not catch that other side of the v. All right, let me erase that and give me room to work the next one. All right, so I have x minus 5 equals the absolute value of 3x minus 2 plus 1. I'm going to subtract 1 from each side, give me x minus 6 equals the absolute value of 3x minus 2. Remember, our first goal was to get the absolute value bars alone. Should have reminded you of that. That's my goal. I'm trying to get that alone, so I just had to get rid of this little pesky little plus 1, and now I'm in good place. All right. Going to remove the absolute value bars by setting it equal to the negative and the positive of that. If I do negative positive x minus 6, I get negative x plus 6. So that is one of them. And if I do the other, I have just positive x minus 6 is equal to 3x minus 2. All right. I'm going to add x to both sides. Give myself 4x minus 2. Add 2 to both sides to get 8 equals 4x. Which gives me x equals 2. And let me see. Let me subtract x from both sides. I get 2x minus 2. I'll add 2. I get negative 4 equals 2x. Divide by 2. I get negative 2. So let's check it up. I have x minus 5. That would be 2 minus 5. Does that equal the absolute value of 3 times 2 minus 2 plus 1? So that's a negative 3 equals the absolute value of 6 minus 2 is 4 plus 1. The absolute value of 4 is 4. Oh, wait, that didn't work at all, did it? Yeah, because there's no way that's going to be negative. Yeah, no, that's not going to work. 2 minus 5 being negative 3 is not going to equal something at an absolute value plus 1, because that's always going to be positive. So that's not going to work. Yeah, negative 3 does not equal 5. Okay, so that solution was no good. Let's try the other one. All right, I got negative 2 minus 5. Well, this one doesn't look much better, frankly. And then I got 3 times a negative 2 minus 2 in the absolute value plus 1. So that's a negative 7. And then this is going to be negative 6 minus 2 is a negative 8. We're going to have that same problem. The absolute value of negative 8 is a positive 8. There's no way this is going to equal a negative number, that's for sure. So it turns out neither one of these solutions worked. So, the solution is either the empty set or no solutions. So you can see we've seen all different things that can happen. One solution, two solutions, no solutions. And what's interesting is that algebraically it doesn't really... sometimes it's obvious when it equals like a single number, because absolute value can't result in a negative value. But for the most part, I had no reason to believe that the equation I'm looking at, D, would have no solution. I mean, there's just, unless you could picture both graphs in your head just right. Now, you have to do the algebra, and it gives you 2 answers. And if you leave those as your answers, you're wrong. You have to check them. Sorry, there's no other way around it. All right. Well, it looks like I got some practice problems lined up for you. I want you to start with just doing this one graphically. Let's review that, and then you're going to do some algebraically. So pause the video while you graph it. I'm going to once again go pull a better looking graph, and you feel free to do so yourself. And then we'll go over it. All right. This is me graphing. Now, don't worry too much about getting the absolute perfect answer here. We're just talking about getting an approximation, because we're solving by graphing, which is approximating. So I have 2 times the absolute value of x minus 1 plus, minus 3. All right, that's going to shift it 1 to the right, 3 down, and stretch it by 2. So let's do that. Move it 1 to the right, move it 3 down, and stretch by 2. Technically, it's multiplying by 2 before it subtracts 3, so I should say we move to the right 1, because we do inside first, then I stretch by 2, then I subtract 3. But it's going to be easier for me to graph doing it this way. So 1 to the right, 3 down, and then stretch by 2. So instead of going up 1 over 1, I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Something like that. And something like that. Okay? All right, let's graph the right-hand side. Y equals negative x plus 1. What are you going to be? You are at positive 1, and you are going down 1 over 1. Bang. Bang. Looks like x equals negative 1 and x equals positive 2. So 2 solutions on that one. And I think if you plug those in, you'll be satisfied with that. 2 minus 1 is 1. 4 minus 3 is 1. Okay, yeah. 2. Yeah, those look good. Those look good. All right, so it's time for you to do some algebra then. Not just graphing, right? I guess we're always doing algebra, but when I say algebra, I mean solving by hand. That's, to me, that's the very essence of an algebra problem. Let me see if I can't find him. Ah, here we go. All right, pause it if you haven't already, and let's get this done. All right, check our work here. We got to isolate the absolute value bars. Get those alone. So I have 1/2 times the absolute value of negative 3x. I'm going to subtract 1 here, so that's going to be just equal to 3. I'll get rid of the fraction now by multiplying by 2. I could have done this at the first step, and I'd get rid of it there, and then that become a 2, and that become an 8. And it ended up being the same thing in the long run. So I get the absolute value of negative 3x equals 6. Now I'll remove the absolute value bars by setting this equal to negative 6, and by setting it equal to positive 6. This gives me x equals 2. This gives me x equals negative 2. And negative 6 has to be 6, 3 plus, 6, 3. Okay, they both work. I plugged them in my head, but they both work. All right, let's solve this one. Again, we need to isolate the absolute value bar, so I'm going to subtract 1 from each side. 5x minus 2 equals the absolute value of 3x plus 4. All right, so that gives me a negative 5x plus 2 when I set it equal to the negative. And I'll work it down here. A positive 5x minus 2 equals 3x plus 4. All right, so that's a negative 8x plus 2 equals 4 when I subtract 3x. Now subtract 2 from each side, and I get a negative 1 over 4, because 2 over 8 reduces to 1 over 4. And this gives me 2x minus 2 equals 4, 2x equals 6, so x equals 3. Now we got to check both of those. Okay, so if I plugged in 3, that's 14, and so 3 definitely works. The negative 1/4, I probably am about as eager to test that one as you were. But no use stalling, right? Okay. I got to plug in a pesky little negative 1/4. So that's going to become a negative 5/4 plus, minus 1 on the left. Of course, that's 1 over 1, which we know is 4 over 4. Because I can multiply by 4 on top and bottom. And it's going to give me a negative 9 over 4. So it had a negative 5/4 minus 4/4 is a negative 9/4. And there is no way that that can be right, because this here can't be smaller than 0. So this has to be a positive number. Does that make sense? Because the absolute value of something can be 0, but it can't be negative. So even if it was 0 plus 1 is a positive number, so it can't equal negative 9/4. So I'm not going to go any further with that. And I'm just going to say that the only solution is 3. Oops, my 3 looked like a curly brace. All right. Okay, if you haven't already, please work C and D. If you have worked them already, let's discuss them, make sure we got the right answer. Okay, I'm going to subtract 1 from each side. Remember, we're trying to get the absolute value bars alone. And I'll set this equal to both a positive and a negative 5. So that gives me 2x is equal to 0, so x is equal to 0. This gives me 2x is equal to 10, so x is equal to 5. And those both work, don't they? Yeah, they both work. All right, let's try this one. You got x plus 4 already isolated in the absolute value, so I'll just set it equal to the negative, which changes all the signs, and the positive. So let me do the negative one first. I get 3x plus 4 equals 3. 3x equals a negative 1, so x is equal to a negative 1/3. And now I'll do the positive. I have x plus 4 equals a positive 2x minus 3. So that's a negative x plus 4 equals negative 3. So it's a negative x equals negative 7. So x is equal to 7. 7 plus 4 is 11. The absolute value of 11, does that equal 7 times 2, 14? Yeah, that one works. The negative 1/3, however, is going to be a little bit different. That's not going to work, because if you plug in a negative 1/3 for x, you get a negative 2/3. Negative 2/3 minus 3 is definitely a negative number, and an absolute value can't equal a negative number. So, aha, I can avoid trying to plug in a fraction. How do you like that, apples? All right. Last two, if you haven't done them, please do them now. And here we go. We're going to take this. I'm going to divide through by that negative. Don't want that there. So I have negative x minus 4. And all right, now remove the negatives. I have 1/3 x plus 4. I'm removing the absolute value bar, excuse me. So when I do, I have to take the negative of this, which is positive x plus 4. And then I have to do 1/3 x plus 4 is equal to the positive of that, which is a negative x minus 4. All right, I'm going to multiply both sides by 3, giving me x plus 12 is equal to 3x plus 12. So I'll subtract the x's over. I get 12 is equal to 2x plus 12. Subtract the 12, and you get 0 is equal to 2x, so x equals 0. And that's not true. When you plug in a 0 for x, you get 0 plus 4 is 4, and then the absolute value of 4 is 4. Negative 4 is negative 4. It's not going to equal 0 plus 4, so that's not going to work. That's a big no. Let's try this one over here. Multiply both sides by 3. Again, you're going to get x plus 12, and this time is a negative 3x minus 12. Add 3x to both sides to get 4x plus 12 equals negative 12. Subtract 12 from each side, I get a negative 24. So x equals a negative 6. I plug in a negative 6, I'll get a negative 2 plus 4 is 2. That makes that as negative is negative 2. And then, so that works. That one looks like that works. So negative 6 is correct. Okay, last one. We'll remove the absolute value bars, make it equal to negative x plus 3 equals 2x minus 1, giving me 3x minus 1 equals 3. So 4 equals 3x, so x equals 4/3. And that one is not going to work, because 4/3 minus 3 will be a negative number, and absolute value can't equal a negative. Let's try the other one. Let's try the positive now. X minus 3 equals 2x minus 1. I'll subtract x from each side. I get, let's see here, 2x minus x is x. And I get negative 2, so x equals negative 2. That is also not going to work, because the absolute value cannot equal a negative number, and negative 2 minus 3 is a negative number. So there's no solutions to that one. All right. What I'd like you to do in closing is to just kind of draw a graph of what would look like if you had a line and a absolute value equation, and you graphed them, but tried to solve by graphing, and you had no solutions, 2 solutions, and 1 solution. Be creative. All right. See you next time.